Okay, so we are now going to go back to the Atwood's machine, but with one change, that our pulley is no longer massless. So the pulley has a mass. Alright, so once again we're looking for the acceleration of the two masses, and let us say the tensions on the two strings. Okay, and this part is also different because if you remember the Atwood's machine where the pulley was massless, the string on either side had the same tension. Okay, but now because the pulley has a mass, that's impossible, because if the strings had the same tension, then the pulley would not rotate, it would not turn, which would mean that the masses would simply stay there, which would be the impossible situation. So please keep that in mind, that in this situation now the tensions in the two sides, on the two sides of the string are going to be different. So we'll tackle this problem very similar to the way we tackled the previous problem, by drawing free body diagrams. Okay, so at this point I would ask you to pause the video, draw your free body diagram, come back and check. Okay, alright, so here are my free body diagram. So for the hanging mass M1, the forces are M1G pulling down, you have T1 pulling up, and then my result of all this is an M1 times A in this direction. Okay, for the second, for the pulley, the forces are T1 pulling it on one side, T2 pulling it in the opposite side, and then the result of these two is some kind of angular acceleration here. And then for my second block, I have once again M2G pulling it down, I have this tension T2 pulling it up, and the result is basically equal to some M2A going up. Okay, now that we have our three diagrams, it's time to start writing our equations. Okay, so once again stop and just pause, write your equations, come back and check. Okay, the equation for the first block is simply M1G minus T1 equals M1A. For the pulley, the torques due to the two tensions will be T1R minus T2R. So we know that T1 times R minus T2 times R is equal to I times alpha. And the reason we are subtracting them, because if you look at this, T1 is going to try to rotate it clockwise, while T2 will try to rotate it counterclockwise. Okay. Now you may argue saying that, hey, but we said earlier that counterclockwise is positive and clockwise is negative, but we're just going to ignore that in all these cases, and we'll just write the equations as the greater torque minus the smaller torque will be equal to the resultant. Okay, if we were to stick with the previous logic of counterclockwise being positive and then clockwise being negative, then we would have to put another negative sign with I alpha, because we know clearly that it is spinning in the clockwise direction. So that's how it actually gets rid of all that. So frankly it's easier to just write it this way. My third equation will be T2 minus M2G is equal to M2A. Okay, now once again we have four unknowns, 1, 2, 3, and then no, this is not my unknown. So T1, T2, A and alpha, these are my four unknowns. Okay, but again, if you assume that the string does not slip on the pulley, then we know that A is equal to R alpha. Okay, and what that does is it simplifies this equation for us. And what I'm gonna do is I'm gonna replace alpha with A over R, and then I'm also going to divide by this R. Okay, you know what? I'm using two different R's. Did I draw an R here? Oh, I used a lowercase r. So let me just fix this and write a lowercase r here, here, and here. Alright, so I'm going to divide the a by r to get alpha, and then I'm going to divide once again the second equation with r by r, and so I'm going to end up getting T1 minus T2 is equal to I times A over over r squared. Now this will be a very common recurring theme, so just get used to it. Make sure that you can do the algebra and everything should work out fine. Okay, so once we have this, you see I can, just for the sake of being able to see things, so I'm just going to move this to the right. Okay, I can add these three equations. Okay, and when I add them up, if you see, I have a minus t1 here, plus t1, minus t2, plus t2. When I add them all up, you see all the t's cancel out, and I end up getting the simple equation m1g minus m2g is equal to m1a plus I over r square a plus m2a. Okay, so at this point I can factor out the g on one side, so I write this as m1 minus m2 times g, and on the other side I can factor out the a, and that this is m1 plus I over r square plus m2 all multiplied by a, and then this ends up giving me my acceleration as m1 minus m2 times g over m1 plus m2 plus I over r squared. Okay, and once I get my a, I can plug it back into the equations and find t1 and t2, and that's something that you guys can just finish. Okay, you can just plug it back into the equations to find t1 and t2.